Hello, everybody. So, looks like we're getting near the end. Basically, 2 weeks of class left. Still got quite a bit to cover because, well, we're mostly just looking at the tools we have to develop games in this course and kind of barely scratching the surface. It takes a little while to see everything. So, the agenda for today is to kind of follow suit with what we've seen, those fundamental concepts that we have everywhere, getting images on the screen, moving them around, having them interact with it, the other stuff, the things we've seen in the other engines, the common points. I wanted to make sure and look at those first in this course because, well, we're very restricted on time. Definitely don't have enough time to cover everything about game engines. So I wanted to look at what they all have in common first. And so we'll look at that in Unity today. There are some things in Unity that are kind of an advantage to some people, can also be a disadvantage at the same time. I think we'll experience some of that today. Right before we started recording, there was a question about the tutorial that was assigned. It was a couple of versions of Unity ago, so some of the buttons have moved and stuff. We'll look at that at the end, and hopefully we'll see all the buttons that have moved since then. Which is another thing that the interfaces go through regular updates. Things get moved around, so sometimes we do have to go look for buttons. It's like, I remember where it was at 2 years ago. The button's not there anymore, so then it just comes down to just digging through menus and different panels, trying to find where they thought a more reasonable place for that button would be. And we'll look at that at the end in case there's anything that has been moved that we don't see in today's pass here. And the plan coming up is we will review this stuff like we've seen, those basic common points to all game engines, right? Loading in our images, moving the images around, getting them to interact with each other. So we'll look at that, and then we'll expand that a little by analyzing what we do, right? Once we get those keyboard controls set up and the images moving and we're kind of controlling the thing, we'll take a moment and look at sort of our thought process as we control the game pieces, and then we'll turn around and have the computer do that, set up some computer controls so that like the opponents in the game chase us down instead of waiting for us to interact with them. And kind of do the same thing we do when we're controlling the game. So we'll go over that. It might stretch a little bit into Wednesday, and then we will move up to 3D and do a pass at 3D stuff to see that a lot of it is still the same. There's very, very little of what we're going to see today that will not also apply when we get to the 3D one. Which one was it? Oh yeah, the 2D animations are the only thing that, when I was thinking about it a few minutes ago, the only thing I noticed that's not going to apply to 3D is the 2D animation stuff. And in that case, we'll need 3D animation instead of 2D, which is handled differently than the frame by frame sprite stuff. We saw a bit of it when we looked at Blender, which actually makes it really easy because Unity will accept the Blender files. We don't have to do any fancy exports or anything. We just load our entire Blender file in there and it'll figure out what we need to do. The only difference we didn't see is we'll have to set up the dope sheet properly. Remember, dope sheet's the traditional filmmaking term for when we're analyzing something frame by frame. I will need to set it up properly instead of, I think the last time we did animations, we just did like, frames 1 through 20 were the walking animation, and I can't remember what it was, and maybe frames 41 through 60 were the flying animation or jumping. And we just chose a couple different frames, but we'll need to set it up a little bit more properly so that Unity can pull stuff from that. But unless anybody had any questions, I guess we can go ahead and jump into it because there's a lot to cover. And again, barely have time to scratch the surface of game engines, but hopefully get off to a good start here. Okay, I assume the silence means no questions, so I'll go ahead and share my screen. And get this stuff pulled up. Open Unity Hub. I guess I could have done this beforehand. And been a little bit prepared. Oh yes, I sent out some files. Did you all see the files I sent out? We looked at the asset store where we can go get a lot of nice artwork and stuff. The reason I decided to go back to just some simple files is it's not an art class. We just need to see how to load in images. And those nice things that we download from the asset store are usually full packages. We'll have animations with like 60 frames in them, and layers and layers and layers of folders with alternate versions and all sorts of stuff. Big, huge, just a big, huge pile of stuff to work with. So, and mostly it's graphical, art-based stuff, and loading in an image is loading in an image. So I wanted to minimize some of that clutter for the things we're going to look at. So I sent out just some single images, which I did not spend a lot of time on. I used that little script that I already shared with you all that just generates the starting point of a 3D human model. And I made it, what I use, green and blue. I made it green and took a picture of it, then made it blue, took another picture, then like raise the arm up so that it was kind of hitting something, but all I did was raise the arm up so it looked more like a slap than a hit. So then took another picture of it. And I also sent out the Blender file. We'll use that when we get to the 3D animations on Wednesday. See how to do that. And a background. So I sent those files out. They should be in an announcement in Ivy Learn. But really, any image will work. I just sent those out to kind of try to minimize the clutter in the graphics. Because just like we saw with other game engines, the computer doesn't really care what file it's loading. We just point to an image file, or we point to 50 image files if we have a big, huge animation, and the computer just loads them in. So there's not really much difference in loading one file or loading 50 files. So I'll go ahead and create a new 2D project, and then we'll look at some of the basic things for Unity. And then on Wednesday, we should be getting into the 3D stuff to see what's common between the 2 and 3D stuff. So that's mostly what we've been looking at this semester, is the things that the game engines have in common, not all those fine details that separate them. Just hopefully building a good foundation to get you all started. What can I call this? Class example Unity 2D. Something like that. I guess the name doesn't matter where I'm at. The delete folder, that'll work. Oh, and I don't know if you all have tried clicking on some of these other ones yet. I can't remember if I pointed it out or not. These other ones here where we create a new project, those aren't templates. Those are different setups. We could start with just the generic setup and customize it. But if we're making like a racing game, we probably want a different setup than a platformer game. So there might be a different rendering, different setup for rendering the graphics, or different options on the windows that we're looking at by default. And or for VR, instead of one screen, we need 2 that are slightly offset from each other to simulate the way the parallax from our eyes. So we're not looking at just one object. They're kind of split up, makes it look a little bit more 3D. So those are like setups on the interface. They're not templates on the games. But for us here, just gonna start with the generic 2D setup. And as this pulls up, one of the things that really helped Unity to become very popular very quickly is following conventions. It is an excellent example of the standard convention that's followed when we write C# code. All of their objects and pre-built methods and all of that stuff is it is like a really, really nice textbook example of the conventions we follow when writing C# code. And along with that, they kind of followed suit with names and things like that. So it is all the proper names for mathematics and physics and computer graphics stuff. Has all the proper names, really nice convention. So doing that with their engine really helped Unity to take off in popularity very quickly, because the people that knew that stuff, that knew all the math that would be involved in that, knew the physics, knew the graphics, they saw words they recognized, and it they were all being used properly, and so they didn't have to memorize what somebody else felt like calling something. It was a really nice convention, so they were able to use the standard name building patterns to figure out what methods were called and stuff. So the people that knew a lot about making games, programming video games beforehand, when they first get exposure to Unity, and this is how it was for me, the first exposure, there's almost no need to go look a bunch of stuff up, because it all follows the conventions and standard naming patterns for math and physics, names that have been around for quite a while and stuff. That helped Unity to take off in popularity very, very quickly. But unfortunately, there's kind of a downside to that, in that I'll close these for now. In that once Unity began to take off in popularity, that's one that a lot of new people would go to because they'd heard about it a lot, or like our situation here. It's such a popular, it's one of the big three that we can't avoid it in an introduction class. But those things that made it take off in popularity that I just mentioned, those conventions, at this level, you probably haven't seen coding like that. You probably haven't seen the basic introduction to those naming conventions we use and how we build up names from small pieces in our code. So it looks like just a bunch of stuff to memorize, and it looks extra hard because you're seeing the final result and not the little pieces we use to build those names. Or one of the words that's going to show up today, I saw it as an undergrad in a 400 level math class that was taken as an elective, just when people are getting ready to graduate with, say, a bachelor's in mathematics. There's a handful of electives they can choose to start preparing for grad school. And I went with abstract algebra. So I saw this word as an undergrad, and I think the number was 403. And it was also in a physics class, which was numbered 408. So it doesn't show up to like 400 level math or physics classes, but it is the proper word for it. But if you're seeing it at an introduction level, it's probably going to seem like a really strange word that just comes out of nowhere because you haven't encountered it in math classes and stuff. So there's a lot of that in Unity too. Part of what is so nice once you know that stuff is it seems so confusing when you just get thrown into it at the introduction level. But as you progress further, it'll hopefully make more and more sense. And it ends up leading to people getting started in the game development using things like Unity, end up having to spend a lot of time looking stuff up. It's like, what do these words mean? This is so strange. It's it seems out of nowhere. The methods names are hard and stuff, but they are really good formats. It's just you probably haven't encountered this stuff in other situations yet, which is going to make it extra hard and just have some words to start working with. So I guess we'll get started here. We saw the other day, kind of started poking around, dragging things around, looking at different spots. And I expressed the point the other day that the user interface here that we're clicking on with our mouse, sometimes it's important that you don't confuse the user interface with the game engine. The game engine is a bunch of text files written in just like the scripts we're going to write. And the user interface is just something that has access to it. So a lot of the words, most of the words that we'll need in our scripts, we can pull right off this user interface when we know how to look for it. I'll try to point that out again today because it can be a little overwhelming, that's for sure. But if we start putting this together, so the first thing we're going to need is to bring in those image assets we saw the other day. And organization is a very good thing. We could just load all the images in, but then we just have a big, huge mess of files. So probably want to create some folders to put them in. So if we right click in the assets area, you'll get this little menu here. We can do a whole lot of things from this menu. I'll be using that mostly today probably. But up at the top is create, and then the different things we can create. And create a folder and bring in our image assets. I'll call them sprites, the traditional name for it. Oh, and before I ever get too far, there's one other thing I wanted to express about the C# and those naming conventions like I just mentioned, how they might seem somewhat confusing at times. There's a bunch of background noise here for some reason. Sorry if that's really loud. Is that in my yard? Sorry, hopefully that's not too loud with the background noise. Somebody next door is cutting grass. I'll try to talk louder. Okay, so before we get started into this, a point that may be quite useful for you. That's really, really annoying. They're not even cutting grass. It's a big lawnmower-sized leaf blower driving around. So hopefully they won't be there too long. It's just kind of writing in C#. That can be confusing to new people. It can be overwhelming. And more, the industry of software engineering in general, not just game stuff, but a lot of software engineering stuff is moving towards low-code solutions, our drag and drop interfaces. And Unity was a little slower than some of the other popular engines about bringing that in. But I was going to point towards this. They did finally get theirs brought in. So if I go to the package manager, I'm not going to use this one today. I've debated on it. And what I finally decided on is that this is still new in Unity, and we're just kind of scratching the surface, which means you're all probably going to want to go look stuff up. And there's a lot more reference material for C#, which isn't going away. They're just bringing in this a visual scripting tool, which the one they chose was called Bolt Visual Scripting. You can kind of see from the picture here, it's where we drag these little symbols around and then make connections between the things, and our code flows that way. It compiles to the exact same thing as a C# script does. So once it hits runtime, or almost the exact same thing. At runtime, it's exactly the same. The difference when it compiles is because of the graphics here, it can send information back. So on those little lines there connecting the different nodes, you'll see, when we use that and run it for like debugging and stuff, we can see the data flowing between those. So you see the data, the numbers or strings or whatever data you have, you'll see it flowing down those lines, which can be very, very useful in debugging. And the thing I decided not to go with this because, like I was saying, there's more reference material for the C# stuff. I was expecting y'all will probably still have to look some stuff up. So I decided to go with where the more is. But you'll notice right here, from the 2021.1 release onward, which is already out, it just hasn't entered long-term support yet. They're still debugging it, basically. It's been released, but they haven't declared it fully debugged or anything yet. But from then onward, we don't have to add that as a package. We don't have to go to the asset store and download it. It is in Unity by default, which also means we don't need external editors to work with it. And it's kind of nice. The text-based stuff, right? Back in the 1970s, that was the only option we had. That was the only option we had. The only way we could give instructions to a computer was through the keyboard. That's not the case anymore. And the biggest thing about the industry entirely changing over to more graphical based things is people resisting that change. Like, oh, that's not the way we did it in 1975. We got to do it the old way. We got to type up complicated words and symbols with the keyboard. So there are a lot of advantages to it. We end up with the same thing because the text file is not what runs anyway. And well, with Unity, we don't need an external editor when we do that. About a year ago, I had to make a tutorial for something that was designed to be done in one day. So I think it's like 10 videos long, but they're short videos, and it was designed to fit in an afternoon. But I posted that on Ivy Learn if you want to, probably busy with the semester right now, but maybe take note of where that, the YouTube address to that tutorial is. You might want to download the PDF, or when you find time to go through it, just send me an email and I can send you the PDF, because we can't load a PDF on YouTube to accompany the videos. But it's a very useful thing. I just decided to go with C# because there's more reference material out there, simply because it's been around for longer. The end result's the same. Laid back in your chair, just dragging your mouse around can be a little bit easier. And machines don't make typos. That's a human trait. So that is coming up soon, and most of our other big game engines have already applied things like that. So you will find them in most of the other game engines as well. Just wanted to make sure and mention that is coming up soon, and it is a good option, because that visual representation helps us understand what's going on a lot better than a text file like we're going to look at today. Any other? Yeah, and it's worth looking into, I guess, is the point there. It just kind of might just have to choose which one you like better, but low-code solutions are showing up more and more often because humans make typos. Back in 1970s and 80s, when most of our languages were created, the keyboard was our only option, but that is no longer the case. And a lot of stuff can be done better through graphics. There's even some stuff where we can set deep learning algorithms just to listening to programmers discuss what needs to happen at a meeting, and the computer will go ahead and write all the software for us. The only thing the human needs to do is come up with the algorithm. Computers can't do that yet. Okay, so back to our example now. So we need to load in images just like we saw. So for organization, set up a folder, call it sprites. And when we go in that folder, if we right click, you'll see these buttons for importing things. We want to import a new asset. And then simply navigate to where those images are. Oh, they're there. And I'm just going to bring them all in. You can do them one at a time or select all of them. And then I went ahead and sent the Blender file, because whenever we get to the 3D stuff, we'll use that as well. But just those still images will be enough for today, and hopefully minimize the clutter while still showing the concepts. So it gets us a couple characters either standing still or like smacking each other. Hopefully be enough to get through this stuff. And background image, which we saw before. This one's it's set up to be tiled, so the left and right sides line up. We can stretch them out, put a bunch next to each other. If I bring two of them in, if I can position it right, you'll see that everything lines up. So they kind of go together. Oh, well, I'll delete it from over here. And then we have our normal options, like we can stretch it out, make it whatever size we want. I'm gonna delete it and bring one back in at the regular size. We can also set that up to be tiled. So over in our inspector, you'll notice the different components we have. Everything's gonna have a transform, and most of our stuff is gonna have a sprite renderer, all this stuff for showing the image. What image is being loaded in, color information, we flip it across different axes. How are we drawing it? That's the one I wanted to look at here. Move those images out of my way, because there's different ways we can draw it. The simple one, like we just saw, we can resize it and it'll stretch out to fit. We can cut parts of it off so that if we make it smaller, it doesn't scale down, it actually cuts off the parts we don't need. Or we can tile it so that more of them go together. And this one lines up on the left and right side, so tiling seems like a good option if we want and make a nice long little street view. But you'll notice a warning came up here, so I wanted to point at this warning instead of fixing it first, like you would see in tutorials that are designed to go in 15 minutes or in textbooks where you only see the finished version. I like to look at warnings and see how to fix them. It might not appear correctly because the sprite is not generated with full rect. So that has to do with the image itself and how Unity loaded in the image. So if I click on the image, you'll see we have something different in our inspector now. We have all the information about the image itself. And here's the one that warning message referred to, mesh type. I might have kind of drifted off before getting to that word, but one of the words in that warning message was mesh type. So over here it says it's a tight mesh, which means everything's set to stay like it is. We can change that to full rectangle. And now if we go back to the actual object, so click the image down in the asset window and change mesh type to full rectangle. And then when we go back to the object, oh yes, apply those. Now if we try to switch it to tile, you'll notice that warning message is gone. So now if we stretch out horizontally, you'll see it just adds more of the image in. It gives us a nice long surface to work with, sort of a level. I'll kind of try to center it somewhere. That'll be important for tiling. When you get to tiling things, when images line up, we don't want to stretch them out because the sizes are kind of set already, which we'll see. It's like a little street, the front of a store, and parking spaces are marked, which means our humans should look a certain size compared to the parking space, right? There should be a set ratio of how big a human is compared to a parking space, which is a standard size. Even though I drew that in a hurry and I can tell from glancing that I didn't get all of them the same size, hopefully that ratio is still somewhat relative. So if we bring in a green object, oh, it looks like the green guy got behind that image. And on different tutorials, you'll see different ways to handle this. Unity has some stuff that's not common across all our game engines. One that would be common is we always have that transform. We always have X, Y, and Z transform. So instead of doing some fancy stuff, we can just adjust our Z axis for 2D games. So here, if we click on the camera, you see that's at -10. So then the background, that storefront, we could put that maybe at a +10. And then all our characters just kind of fall in between them at 0. Seems a good place. Or any number between -10 and +10 to kind of lay, if you want to define where the layers are on them. So that gets us an image in to start working with. And then we'll do quite a bit of stuff to it today. So to start with, we probably want to move that around. And this is one we hadn't seen in the stuff we looked at earlier. We didn't really have a world that went beyond our camera view, right? It's like our camera can only see a little piece of this. So one thing that's very common that we want to use is camera follows, which can also be kind of difficult. It can be quite a chore to get your camera to follow your character correctly. However, one really nice thing they have in Unity is some really, really good programmers tackled that problem and spent a while and got together a generic version, sort of a plugin we can use from our interface here and not have to worry about the coding and get a decent camera follow very, very simple. So we'll look at that here very shortly once we make our character move. We'll need a few things. Might as well set those up first. So, well, we want our character to move, so we're going to need to apply some physics to it. And we saw before, anything we want to apply the laws of physics to needs to be a rigid body, which we can go in Physics 2D and find it, or it's a whole lot easier just to search for it. The 3D stuff is just the actual name, and then the 2D specific stuff, they just tacked a 2D on the end. But we'll also need a border. Pictures are in the way again. There we go. That way I can get to that button. We'll need some sort of border defined around our character. So I'll just go with a box collider. And remember, with your mouse in the middle, you can hit F and it'll bring focus to whatever object is selected. Probably don't need that much space around it though, because that covered the whole image, even when the arms extended straight out. But the simple collisions, like what we would do, two full box colliders bumping into each other, that might not cut it in this game, right? We can see from the images, well, this probably isn't going to be enough to be a game. This example, I should use that word. We can see from the images that there's also a slapping animation. It's a really quick way to get that effect. We probably want to do a punching animation, but so I had the generic character already drawn, so I just loaded that in and raised it up, and it looked like a slap. I was like, that's good enough. But to make a punch, I would have to add a whole lot more bones in. You can see how your fingers are set up. We have 3 bones, so I would have to add a whole bunch more bones in order to curl the fingers around and make a punching animation. So I went with something quick for today's thing, which hopefully cover the concepts, but there's that slapping animation. So we don't want things to happen just because our boundaries of our characters bumped into each other, right? Because they might not be in the right animation frame to trigger that event. So we're going to look at another way to another type of trigger here as well. I'm going to make the bounds nice and small, just kind of right up against the character, because really I want to use those to make sure he stays in the right area. And I'm going to do something here. So we need to define the right area. We don't really want our character going above the sidewalk. The character walking up here by the windows would look kind of strange if his feet was way up there. Or we have that definite bottom, and then there's obvious left and right sides to our scene. So your first instinct might be to put a box collider on that. So I'm going to do that to show you what's wrong with putting a box collider there. So I add a box collider component to the storefront, then set that for editing, and I don't know, maybe his head can go up about that far. Just kind of guessing, stretch that out. something like this. But there's a slight problem here, and that is that a box collider, well, I'll wait till it runs. There you go. It's kind of hard to see. We're zoomed way out. We'll fix that here shortly. But do you see something that seemed to go very wrong there? It shoved our character all the way outside of that collider range as soon as it ran. And that's because box colliders are set to go external. So what we actually want to use here is just an edge collider. So over in the components, if you click the 3 dots, there's a remove button. So if we remove that, instead of a box collider, we also have an edge collider, which gives us just a solid edge so that the character can interact with. And on this, you can just grab a point on it. Oh, go to edit, and we can just grab a point on it and just kind of drag it up to about where we want it. And then do that with pretty much all of our points. Where's that one that Troy got? Oh, it must be there. So that we get roughly the shape we want. Which still want kind of a box shape because we have a nice rectangular thing here. But we can't use just the generic box, so we kind of have to use this edge to draw our own box. That way, when the character bumps into that, it'll stop moving, which is really all we need from the box collider to keep our character restricted to our game space. And you'll notice that if I want to move something, I can just add more points in there. So really, it's more like a polygon thing. And it's a little more time consuming than putting a box collider in there, but we get a lot more refinement. We can specify things much more explicitly. So when you're not under tight time constraints, such as in a classroom, that can be a better option to just define every edge where you want that collision to happen, instead of just simply putting a box or a circle or something that might be the best you could say is close enough, and actually define the polygon you want for it. So that'll give us an edge, but we'll need to move so we can see that happen. So I'll bring focus back to the character. And we kind of saw movement. Oh, there is one issue here, isn't there? Let me run this again.
I'll have to log off that 1/5 in a little bit for my doctor's appointment.
Okay, that's fine, Zach. It's being recorded, and you'll be able to check this out later. And as always, during the recordings, I tried to talk slowly and clearly so that you can watch the recordings at double speed without too much trouble.
Thank you.
Or yeah, adjusted speed, right? Flip it up to double speed to get through the parts you don't need to see, and then pause and rewind, all that.
Okay.
But did y'all notice that the character fell down? It started up here. As soon as the game ran, he went this way. And that's because when we applied the laws of physics, sort of the default on Unity is a platform game. So gravity is turned on. But from our scene, we don't really need gravity applied here, right? So the easiest way to get rid of that is just set the gravity scale to 0. Just say, okay, gravity doesn't affect us at all. Might also need to freeze the rotation. These aren't nice symmetric images here, so there's a good chance that they'll spin around and stuff. The computer will detect that the center of balance gets off when they bump into each other and stuff. But I'm going to wait till that happens before I come back and check that box. But more often than not, you want to have that box checked. I usually often feel like that should probably be the default to have that checked, and the default is unchecked, but I'm going to wait until we see it today before we do that. So that gets our bounds, which we can confirm they work, and we can move and bump into them. The character's not going to randomly fall down by gravity that seems to be pulling sideways because of how the graphics are set up here. So we can probably go ahead and start making that character move. And we saw this before. Movement is pretty much always unique. It is really, really hard to generalize movement. Even when we start doing stuff, we'll do very similar things, but we almost always have to adjust it for the animation we're looking at, the sizes, make little adjustments for every little thing. So people have built some things that try to generalize it, but it's a unique thing. It doesn't generalize very well, but it's not, it's not hard to set up our movement. We just have to do it in a script. So I'm going to add a new component to get a C# script. Actually, I'm going to do this differently. I'm going to come up here, and with organization, I'm going to create a new folder and call it scripts. And then I'm just going to go into this folder and then right click and create a new C# script. And I'll call this player_move. And I decided to do it this way because I don't think we saw this alternative the other day. We were using the add component button. Well, as soon as this catches up, but along with the add component button, when we have a script, we can also just drag it over and add it in there. Oh, I don't want to drag there. Apparently in the newest version of Unity, we can't drag it to the inspector. But if we drag it up here, oh, why is that not adding in there? Okay, it added that time. I must have been dragging incorrectly when I was talking about it, but let me remove that and try that again. Remove component. So you see there's no script here. There's no script in. So if I drag this over, I guess I have to hover over the add component button. That's no use. You should be able to just drag it anywhere in the inspector and it would drop. But drag it over here, and now that script is connected to the player movement already, instead of doing it through add component, which just comes down to preference. Whichever way makes more sense in your mind. Create the file over here and then drag it over, or select your game object and hit the add component button and then drag the script to whatever folder you want to keep it in. Either way ends up working the same. But now we can go in and edit those. And just double clicking in Unity will open an external editor, which is another advantage of the bulk visual scripting tool, is it will be in Unity. So we don't have to use external tools to do it. Get this out of the way. And I always like to start by just some setup things to get this back to sort of the way I like to have mine set up. And we won't be doing a whole lot today, but before long, your games are probably going to get much larger very quickly, right? And if you're scripting them in C#, it can be easy to lose track of the closing curly braces. The opening curly braces are usually right next to the keywords they go with, but the closing one might be a number of lines away, and there could be another 10 sets of curly braces inside of them, which makes that closing one hard to keep track of at times. So it can be good form to go ahead and label those, which is just a comment. So 2 // for C family of language comments, and just mark what that goes with. That's the end of the start method. So we always want to have these two methods, or usually want to have these two methods. The start method will run once when the game first starts, or when that object that the script is attached to first appears in the game. The start method will run once while the initialization things. And then the update method happens every frame. And there's actually 3 types of update. We're only going to stick with just the basic update that happens somewhere during each frame of the game. But we also have late update, which that will be the very last thing that happens in the frame. So the very last thing is the late update. And we also have fixed update that happens at a set amount of time, which varies slightly from the frame rate of the game, because the frame rates of the game kind of float. In the early days of game development, they tried to set those up, tried to do rigid times, but it would cause problems because some frames of our game are more complicated than others, which means some of them need more time and some of them need less time. And when a lot of frames need less time, it starts to make our game seem kind of jumpy. And when a frame needs more time and there's not enough, then that means there's instructions that don't get ran. And then the whole thing's just going to crash and fall apart. So that fluctuates a little bit in order to keep everything running smoothly. So when we do the late update, it gets away from the frame rate of the game and just does it on a fixed schedule. In player move definition. And yeah, labeling closing curly braces can just be a good idea. So we kind of saw our syntax for C# the other day. We have to say whether things are private or public. And if there's no keyword in C#, if we leave off the private or public, it will be implied that it's public. So these that are started, the start and update, those are implied to be public. We could go back and explicitly state that they're public and it wouldn't change anything. In Unity, when we do public variables, if we explicitly make it public instead of implying that it's public, explicitly state that it's public, we get a spot on our interface so we can access. And the speed one is a really good thing to do that on. I'll just leave that blank. Whoops, public. The data type, so it's a float, and then we'll call it speed. And that's a really good one to have on our interface, because then we can adjust that while the game's running and figure out what the value should be, instead of change it in the script, rerun it, change it in the script again, rerun it, and try to hone in on it that way. We can actually adjust it while the game's running if it's on the Unity interface when we're debugging it. But then we also need a reference to our character, or at least part of our character, something about our game object, which there's lots of things about, all of these components. There's the transform data, the sprite renderer. It's going to relate to physics. Movement relates to physics, right? We're moving a physical object. So that's the component we want. We want the rigid body 2D component. And then all of these things are just variables that we can access from that rigid body 2D component. So a quick way to get movement set up is to access that rigid body. This one doesn't need to be public because we're going to refer to ourselves. So we can keep that private. It's not accessible from outside of our script. We don't need anything else to access this rigid body 2D type of data that we'll just call a player. It's a good name for it. But we will need to initialize that. So in the start method, we can set that up by saying player is going to be assigned, and this script we come back over and point at everything. So we can find the stuff we need from the interface again. Our script is attached to this green object, which I'm going to rename as green guy. The stand was just the image, but we have a couple images we're going to load in there. So the script is attached to the green guy, and there's other components attached to it. In particular, we want to access the rigid body component. And we want to access the rigid body to change the transform. So if you go looking up in different tutorials and stuff or quick things, you might see places where people just access the transform to change the position, which is ultimately what we're going to do. But remember, rigid body, that's what we have to have in order to apply the laws of physics. So if we access the transform component through the rigid body component, we'll get the laws of physics. So things like friction, we don't just suddenly come to a stop, right? If the character is at a full run across the speed, he has momentum. And it's going to look strange if we go from a full run to a sudden stop, right? Because we know that's not how it works in the real world. So you might see in some tutorials and stuff, they'll just directly access the transform. But if we get there through the laws of physics, we get those other little things like friction and gravity and center of balance. So that if we run full speed into something, we'll take a tumble. So it'll look more realistic right off the bat, more realistic type of movement. And well, we're looking at the thing we want to get one of the components. And so this other day, everything about that is called a component. So the name building convention in C# is, well, words are spelled out in methods are in camel case, methods are in Pascal case, and variables are in camel case, which means the words are jammed together and each subsequent letter or each subsequent word starts with a capital letter. In Pascal case, the first letter is capitalized, and in camel case, the first letter is lowercase. So following, and then we build up our method names from a few keywords like get or set to access the value, or to change the value, we use set. Or with Booleans, we might say is or has. And we have a handful of keywords in the naming convention that these methods are built up from, which was part of the appeal that helped make Unity so popular so quick. Is it was a very nice example of that. So people that already knew this stuff and knew all the names from math and physics, well, they didn't have to look things up. It was just there. But that's not the case when at the introduction level in C and Unity. Because of the popularity of Unity, we can't just ignore it at the introduction level. So this kind of looks like a mess. And then with the component, there's lots of components, right? Whoops. We have a transform component and a sprite renderer component and a rigid body 2D component and a player move script component and a default material component and a whole lot more we could add. So we have to say what type of component we want. And in most cases, it's going to match this. Unless you set your data type to be like something generic, like said, we just have a game object, you're probably, the type that goes here will match the type of data you said you had. Rigid body, we want to grab the rigid body 2D component, and that's a method, so we need the parentheses to say, sort of do something. Which we saw before. I just want to kind of go nice and slow and make sure all these things are making sense. And hopefully you're getting this an inkling of the idea of the name building patterns and where these things are coming from. So that when you see it referred to in reference material, since this is the introduction level and we're very restricted for time, So we won't cover everything. So you're all probably going to see other stuff in other material. You'll be able to see where it comes from and expand on it, is what I'm hoping there. All right, now that we have something, we can make it move. And the same way we grab those components, we can grab inputs. We could just ask for the key press, which would work on a keyboard. But if I suddenly plugged up an Xbox controller to the computer, it'd be nice for that Xbox controller to automatically work, right? Or a PlayStation controller. I don't think those have USB ports, but a controller, some generic type of controller, as long as I had a USB port, I could plug it right in the computer and Unity could detect it's there. And while the labels are going to be very different, there are some things they have in common. They're all a bunch of inputs. And under edit, we have the settings for this project. One of those is the input manager. And that's what all of our controllers are going to have in common, whether we're using the keyboard, an Xbox controller, some generic controller we picked up at Walmart because we were short on cash, and when a controller broke and it had a USB plug or something. It's all going to have an input. So those are labeled as axes, which relates to dimensions. We talked earlier in the semester about vectors and using that word, and a vector is a collection of numbers, specifically a collection of numbers that represent the dimensions, which are the parameters to describe something. You probably know axes from like the x-axis and the y-axis in math class, right? Our normal Cartesian plane where we plot out our points, those are axes, but those are dimensions, the x dimension and the y dimension of two-dimensional space. So axes is another name for the number that represents the dimension of a vector. So that's why all these things, the horizontal and vertical, those we definitely think of our axes, because that's what an X and Y, like we see in math class, is. But things like our fire 1 button, which is left control on the keyboard, or mouse 0, I think that's left click, or the jump button, which is the space bar on a keyboard. And if we plugged up a different controller, Unity would register that and change it. That's why those are axes. They might not seem like it, but the word axes means that's the name of a number in a dimension of a vector. So just like X and Y axes that you're familiar with are the names of the dimensions in 2D space, two-dimensional space. All of those are numbers in some vector. So they are axes. But we have our horizontal and vertical axes. So we can just use those names and ask for those things directly. And that way, it doesn't matter which keyboard it is, or if somebody reconfigured the keyboard for their default preferences for gaming or something, Unity will detect what the input is and adjust it to those axes. And they return a floating point number. So everything on the axes returns some floating point number between -1 and +1, with 0 being not pressed. So 0 is not pressed, and like the horizontal axes, A would be -1 and D would be a +1. Alternatively, we can use the right and left arrows. That might have made more sense. The left arrow is -1, 0 is neither one gets pressed, and the right arrow is a +1. I think I said that correctly. But a floating point number is what we have. So we need a spot to store floating point data. I'm just going to abbreviate horizontal here. And we'll assign that. We're going to look at the input, that thing we just looked at. That input manager had a bunch of things. We want to get one of them. So that's the name building convention. When we want to access a value that's already there, we say get. If we want to change it, we say set. So these words are all built from something, which y'all probably haven't seen this level of programming course. But we can get an axis from that input. And all of those axes had names, which we could rename if we wanted to. Right, those were just text fields that we can fill in that name value. But by default, there was one called horizontal and one called vertical. So we'll look at that input manager and we'll get an axis value from it. In particular, we want to know what the vertical axis is at every point in time, or each frame of the game. We'll relook every frame of the game. Anything else I had here? So that's for turning around. We'll do that after the break. Oh, and move it. So now we can move that because well, we have that player object representing our game object. We created this player thing, and we referred to the physics component. That way we get all the nice laws of physics applied. Things like momentum. We don't come to a sudden stop from a full run. There's still that momentum pushing our mass forward that makes it really hard to suddenly stop. The notorious hitting a brick wall. That hurts because the brick wall will bring us to a sudden stop, but there's still a lot of forces implied if we were at full speed when we hit that brick wall. We want to see that in our game. So if we go through the physics object, then instead of just adjusting the transform data, we can access those physics components. One of the standard term for this, what relates to speed, it's a vector, so that it has more than speed. It has speed and direction we're going in. The speed and the direction that speed is applied in. The term for that's velocity. So we can access the velocity and just change that to some new vector. Oops. So the player's velocity is going to be assigned a new vector 2. And everything that we do in game engines is in vectors. Some game engines kind of backed away from that, but like I was saying, Unity used all the proper terms. So we will use the word vector a lot in Unity. Vector 2, vector 3, or however many dimensions we're working in, because not everything is the 3-dimensional graphics. We might have some time stuff going on or other issues going on and need even bigger vectors to work with. But for the most part, 2 and 3D is what we're going to see. And a 2D vector means we have 2 components. We have that X component and the Y component. And we just grab those from our input axes, whether the keyboard, the mouse, the controller. One of the numbers that describes the vector data coming back from the user inputs is we grab those numbers, so we just need to change our velocity by that much. So the one we grabbed, which again, that is a number between -1 and +1. So 0 means not moving. -1 would be to the left, +1 to the right. And we'll multiply that by our speed to determine how fast we should be going. And same thing for our Y component. We'll take that -1 to +1 range of value we got and multiply that by our speed to determine how fast we should be going in that direction. Then I'll hit save. Has anybody had a trigonometry class? It wasn't a prereq for this, but some of y'all may have had that pre-calc in high school. Okay, I see a thumbs up. So obviously there should probably be some trig functions there, right? It's usually covered briefly in trig class, reference angles, but after we get through that intro to trig class, we use reference angles all the time. If we measure from the nearest x-axis, cosine gives us our x value and sine gives us our y value. So really we should be doing the cosine and sine, because obviously if we're going at a 45-degree angle, it's going to be twice as fast as it would at either straight up or straight over. But I'm going to omit that for now. That should be obvious if you've had a trigonometry class, just to apply the cosine and sine to smooth out those angles between straight over and straight up. But if you've had a trigonometry class, that should probably be obvious that those are needed, and just use the reference angle. If measure from the closest x-axis, and then your x is always cosine and your sine is always y. Your y is always sine. So that should get us moving. Just a quick generic move. That's sort of the starting point you'll want to look for whenever you go to make a character move. And that should be enough that we can check our bounds. At least the top and bottom. And that right there is part of the reason I use the text editor instead of Visual Studio, because on Visual Studio, you have to wait for it to compile twice every time because it automatically saves. I was able to put off the compiler until I push save. So if we run this, uh-oh, I appear to have missed something while I was talking. Have the script there applied to it. Oh, the speed still set at 0. I should, but I forgot. If we go to the game tab, there's an option here to maximize on play, or you can just change the scale. Since the character is kind of small, I'm going to go ahead and hit that maximize on play option. I was thinking I forgot something, and all I forgot to do was give it a speed. You can see over here in the corner, the speed variable is still set to 0. Oh, whoops. But apparently I can't adjust that when maximized, so maybe I won't click that option. That's a useful option at times, but yeah, if you're going to need to change values while testing it, as you can see, it doesn't move, but if we give it a speed, I don't know, maybe 3, now it moves around. Maybe 2. And here I'm kind of using my intuition to look for a speed, because that is very quick drawing, just a starting point, but those are supposed to be parking spaces. And while I've never sat there with a stopwatch and timed it, I do have a kind of a feeling about how long it takes to walk across the parking space, right? That shows up in our daily lives. So I don't know, what is that? 2 seconds to get across the parking space seems kind of long, but maybe not that much. So try like 2.5. That's probably a good speed. If we go up, you see we hit that edge collider while our character's still standing on the ground, on the sidewalk, and go down, we hit the bottom of it. So you want to use, so what do we see there? The edge collider was new. Box colliders can be a little bit easier. And then that edge collider we used just drew a box, but a box is outside. In this case, we want to be inside, which is usually going to happen on our levels. And we get a lot more control off an edge collider. So when you're not pressed for time, that can be much better, because then we could maybe, if I zoom in on it, then we could go ahead and set up a polygon and perfectly trace the edge of that character, so that there's not this gap here where things are still counting as a collision. Could be a useful thing, but it is time consuming, that's for sure. And set up polygons that way. So the edge collider can be really nice. Then the convention on how method names are built, use get and set a lot. Get, and then the thing we want to retrieve the value from. Or if we're going to change it, we say set. Like if we wanted to dynamically change our components, we could say set component rigid body 2D and maybe dot gravity to toggle gravity on and off for some reason or another. That was just the first one that popped in my mind that I knew was there. But we're getting something that's already built, and we can find the name of it over here. So also, as you look up different reference material and see these words, try to look around your interface and see, make sure you can find the stuff there and follow that pattern, so that over time you have to look up. There's less and less that need to looked up. Same thing with our input manager. We access the input manager to get the axis off of it for both our horizontal and vertical. Got us some numbers. And then instead of directly changing the transform, which is just our position, we went through the rigid body 2D, which is the laws of physics. So then we have all the normal laws of physics that we're used to. Friction is probably going to apply here. Oh, and the speed's still at 0. So also after you find, oh, not 25. After you find those values, make sure you change them when the game's not running, because it goes back to what it was when the game's not running. If I start moving and let go, you see it doesn't stop immediately. It has to wait for friction to slow it down to a stop. Like I'll try to let go right as I hit this second white line here so you can see that. So he's moving. And when I let go, he doesn't stop immediately. It's like the laws of physics apply. So that's why it can be a little bit better to, because instead of changing the transform directly, use the laws of physics to change the transform, because they're built in there. And velocity is the fancy word for speed that includes the direction that that speed is happening in. Like 30 miles per hour north is different than 30 miles per hour northeast, because we're going in different directions. Or 30 miles per hour south. We'll end up at a different spot. So the direction matters as well. So that gets our guy in there moving. All right, time for a break, but one quick run before we take a break, just to point out something that's kind of a problem here. So I was thinking of like the Street Fighter games or something, right? There's that big long street we have to walk down, which our character can do. Oh, I forgot to change the speed. I just made a point to express that. So remember to change the speed. So we have that big long thing, but our camera doesn't see the whole level. It's actually zoomed out way too much here. We don't even see our character, and our character can leave the spot we can see. So first thing after a break is we want to address that. We want our camera to follow that character and maybe start closer to our character so that we're not looking at such a big area overall. Does anybody have any questions about that stuff so far?
I don't have any questions about it.
Okay. Did any of the boxes that were missing on that tutorial appear there yet?
I'm not sure. I was looking at it. Didn't really see anything. Well, I guess we'll have to look at that.
Okay, yeah, we'll look at it at the end, but does 10 minutes sound good?
Yeah.
All right, we'll get back to it at 2:26 then. See you all in a few minutes.